This video covers the dplyr package, which is very useful for manipulating data. So we are going to, in the next couple of videos, talk about dplyr and tidyr, which are both packages in the tidyverse. Dplyr is going to be used for most of our standard sort of subsetting of rows, arranging of rows, subsetting of columns, creating basic new variables. Tidyr is going to be really useful for creating new columns and reshaping our data. So when you're going through this code, if you're typing it in, make sure that you run library tidyverse so that you have access to both of these packages. So some of the basic commands from dplyr that we're going to look at are what you see there. And really, you can break this into just a couple different types. So filter and arrange are functions that work on the rows. Select, rename, mutate, and transmute work on columns. And then group by and summarize will do very basic numeric summaries of your data. And so this is what we'll go through. We're just going to deal with the first couple in this video, and later on we'll deal with summarizing our data. So just to recap, why are we in the dplyr package and in the tidyverse? Well, remember that these functions are all built to be fast. They have good defaults. And the best part is that all of these packages are going to have a similar syntax. That's one of the biggest pains about learning R, is learning all the different syntax people use. So the syntax for the tidyverse functions generally are the function name, the data frame or tibble that you want to be working on, and then whatever actions or things are needed for that function. Okay, so let's start with Tibbals. So Tibbals are just special types of data frames that have better printing. It's essentially all they are. And so if you have a data frame already or a matrix, you can easily convert that to a Tibble just by wrapping it, is what we would refer to. And the function that you would wrap that with is the tbl_df function. So let's go ahead and grab some data. So again, we're going to put off reading in data till later. But let's grab some data from the layman package. So you'll need to install that package if you haven't done so already. Library layman gives us access to a bunch of different data sets about baseball. So this is baseball data going back to the 1800s. So one of the data sets in there is the batting data set. And so the traditional sort of standard way of looking at a data set is this head function. So this will allow you to see just by default the first 6 rows of the data. And here we've used n = 4 to say I just want the first 4 observations, the first 4 rows. And so this is what that would print out. And this is fine. It does let you see the columns and the first 4 rows, but if you had, say, 100 columns, this thing would just keep line breaking down, and then it would be really hard to look at. And we also don't know how many total observations we have. We don't know what kinds of columns we're dealing with. So there's a lot to be desired in the way that this data set is printed out. So batting is just a data frame. We can convert it to a tibble by running this function here. So we're wrapping batting with this tibble function, and then we're overwriting that object. And so now whenever I run batting, I don't need to even run the head command. By default, we're going to print out in a nice way that's easy to read and gives us lots of information. So we can see here that this is now a tibble that has 102,000 observations and 22 variables. Here are the columns and the types that each one of those columns happens to be. And so again, this is just a really nice way to display your data. And one nice thing is a lot of the functions that are in the tidyverse, such as readr, all the readr functions and the readxl functions and the functions that come from Haven, if you read in data with those, they're going to be read in as tibbles to begin with. So you don't even need to do this wrapping. But this is a useful function if you already have a data frame or matrix that you want to convert. Okay, so now we have a tibble that we want to work with. We have a data frame that we want to do something with. We've seen how to subset the rows using the filter function. So here's just an example. Take that batting data set, and let's only grab where team ID is Pitt. So only the Pittsburgh Pirate games, or players. Of course, we can do our compound logicals here, so a multiple filter. So team ID Pitt and year ID 2000 returns only team ID Pitt, year ID 2000. The other common thing that you want to do with rows of a data set would be maybe rearrange them. So the arrange function can reorder your rows. So here we're reordering the batting table by the team ID. So this is going to go alphabetically smallest to largest. So I think there was a team back in the 1800s called Altoona. And so these are the it's ordered in that format here. Now notice we did not overwrite the batting data set here, so this just printed that out, but it did not sort of copy and replace it over it. You would have to do the same thing we did here, where you would overwrite the object if you wanted to save that. You can arrange by more than one variable. So here I'm arranging by team ID and games played. So smallest to largest alphabetically by team ID, and then within that, smallest to largest by games. And of course, you can do it descending on the game, so you can do it opposite, so largest to smallest. You can do the same thing on team ID if you wanted to. So DESC will do largest to smallest instead. So those are the two major things that you're going to do with your rows. You're going to subset the rows, and then you might want to reorder them so you can look at them a little bit more easily. Okay, and then we can move on to what we might want to do with columns. So we've seen in the past through sort of just your base R notation how to select, say, one column, or to select a number of columns that you could find using the square bracket notation. Well, there's a select function within dplyr that is really, really nice because it's going to allow us to easily select columns that, say, all have the same letter that it starts with, or all share some same characteristic. So just a very basic example of that. Let's select from the batting data frame the column called x2b, which represents doubles. And so you can see here that this returns just that column, but this is a little bit different than, say, doing the $sign. Remember, if we did something like batting $sign x2b, we would actually return a vector. So let's jump in here really quickly. So if we bring in our layman package, and I convert my batting data set to a Tibble, do batting $sign x2b, and notice that returns a vector, right? So this is simplifying on return. So by default, this $sign is going to simplify if it can. So it simplifies the return. It's just going to be a vector. Whereas when we do the select, it's not going to simplify. It's going to make sure that it returns the same type of object that you gave it. So we're returning a Tibble here instead of a vector. And so that's really important to know, because if you were to write your own function or to be doing things, you need to know what kind of object you're getting out, because how I access a Tibble is different than how I'm going to access a vector. Okay. So of course we can select more than one column. That's no problem. So I just separate the columns that I want by commas over here. And so as you start to do more and more operations, you could think about doing them all in one line. So one thing that you sort of often do as a new programmer would be separate everything you do out into separate lines. So I would do a filter, save that as an object, and then I would select from that, save that as an object, and then arrange. Well, to do that, you need a bunch of intermediate objects that you're saving over. And so that's just a lot of bookkeeping and a lot of memory storage. Oftentimes it's better to just run them all at once. And so this is your standard traditional way of running multiple functions at once. And how you would have to read this would be from inside out. So essentially the innermost function here is filter, and I'm saying filter the batting data set by team ID pit. And then with the result of that, which we know is going to be a Tibble, I'm going to select from that Tibble player ID, games, and doubles. And then from the result of that, which I know is a Tibble, I'm going to arrange the rows descending on doubles. And so you can see that's what we get here. And so that's really kind of difficult to read, especially if you did even more nesting of functions. So there is this lovely piping or chaining operator that can really help us out. So this piping or chaining operator comes whenever you read in the tidyverse. It's actually from the magrittr package. And this can essentially be read as a then. Okay, so what you can see here is, or how you would read this would be, take the batting Tibble and then filter that by team ID pit, and then with the result of that, select player ID, game, and doubles, and then with the result of that, arrange descending on x2b. And so you can see how that's just a much easier way to write your code and to read your code than this deeply nested way of doing it. Okay. Now, piping and chaining doesn't work on every function that you'd want. Here's the sort of generic way that it works. So if you do x pipe y, that actually is doing this argument here. So it's doing f of x comma y. And so that's why it's so important that all of the functions within our tidyverse work with this same syntax. Function, then the data frame you want to work on, and the actions. This allows us to do this piping or chaining across multiple functions that we're doing. If you were to do multiple chains here, how this gets interpreted is, of course, f of x, y for the first bit, but then that'll be the first argument for g of z. So this is exactly how we ended up nesting when we had to do it by ourselves. So I'm not going to require you to do the piping or chaining, but I will say that it makes your code much more readable, and especially for others. So you might know exactly what you're doing, but when you share your code with other folks, doing this piping and chaining can be quite nice. Just remember to read this thing as the word then, and that will help you parse through the code. Okay, so I'm going to start using piping and chaining as we go. Let's see some of the really neat stuff that the select function can do from the dplyr package. So here I'm saying take the batting tibble and then select all of the columns from x2b to hr. So these are all the columns that are sort of next to each other between those. So that just involves x3b as the one in between. We can also use these sort of regular expression matching type things. So we can say grab all the columns that contain a capital X. And so now I've grabbed those two columns. Those are the only ones that have a capital X in their name. I can grab any column that starts with a capital X. Happens to be the same ones here. I can grab any column that starts with a capital X, ends with ID, or is the G column. And so now you can see I've got doubles, triples, player, year, team, and league ID, along with games. So this is the real advantage of using the select function, as opposed to, say, using your standard notation. You can use these ways to easily grab things that are common. Another thing that you might want to do with columns would be to rename them. So, that x2b and x3b, those aren't great names. So what we might do is take the batting data set and then select all of the columns that start with X, ends with ID, or is the games column. And then with the result of that, let's rename. So this is the function that will rename your columns. Let's rename the x2b column as doubles and the x3b as triples. And so you can see that we end up getting a little bit better description for those column names. Okay, and then the other thing that I want to mention with the select function is every once in a while you just want to change the ordering of your columns. There might be, whenever you print out your tibble, right, it only prints out the ones that you can see, and then the rest of them go down here. And so there might be one at the end that you really care about that you want to be able to see when you print it out. And so the way to do that would just be to select those columns that you want to see first. So maybe it's player ID and home run, and then use this everything function, which then just says grab all the rest of the columns and put them here. So we now know how to deal with our rows and our columns. What we'll do in the next couple of videos is talk about creating new variables and creating some basic summary statistics. Now, one nice thing about a lot of the newer packages is that they all have cheat sheets out there. So here's the data wrangling with dplyr and tidyr cheat sheet. And so this goes through a lot of those functions that we just talked about, the filter function, some other ones that we didn't mention, that can be really useful and a great reference for you as you're going and trying to learn this stuff.